Hey everybody. Okay, getting started here. So in class on Wednesday, we got an introduction to Project 5, which is the REST API project. And as we saw, it's really pretty different than projects 1 through 4, right? We created a new Maven project in our repositories, and we spent a good amount of time just working with it to understand that there are two parts to this project. We saw um, we saw that there was the Jetty over here, and this is the web container that runs the REST API, runs the web service. And it's still, yeah, there you go. It's still a little early this morning. I guess my computer's not completely warmed up. So I'm launching the web application over on the right, and then over here on the left, this is where we can. We don't need debugging anymore. This is where we can run the command line program to interact with the web application. And recall that out of the box, the web application is the simple dictionary program, right? It stores key value pairs in a dictionary, a word and its definition. And you can do things like query it, et cetera, et cetera. You can add to it, you can query it. And the whole idea here is that I wanted a working example out of the box for all of you to then explore, figure out how the two pieces interact with each other, and then evolve it into the airline application. And we'll spend some time in class, let's see here, not this coming week, but the week after that, beginning that refactoring. It's a good example of refactoring, but I want to refactor through test-driven development. And so to prepare us for that, I created this bonus lecture to show you and walk you through how this application can be tested, because we have to test the web app in a different way because it's much more complex than your command line application and the code that underlies it. And so that's what I'm going to talk about now. I think I'll be working mostly in IntelliJ because what we're doing is authoring and running unit and integration tests. Okay, so we learned about, I'm going to first look at the servlet class. So remember what the servlet is? This is the code that runs when your REST API is invoked. It's the code that has like do get, which responds to HTTP GET requests, and do post that responds to HTTP POST requests. And the logic itself is pretty straightforward. What does it do? It gets a particular value of a parameter from the request that's sent in. Remember, this HTTP servlet request is this object that Jetty, the web container, provides your server that represents the request itself. So you may recall it had things like the URL. You can get the parameters from it, right? So if you go and look at what getParameter actually does, it calls request.getParameter. This is an API from the servlet. That is a method from the servlet API itself. And the whole idea is that, again, your code is provided with this HTTP servlet request and HTTP servlet response, and it does something with it, right? This is a great example of programming to the interface, where the do post method is inherited from the superclass, and the superclass here is, go up to the top, HTTP servlet, which is a Jakarta servlet, or standard API. It is an API from the servlet standard. And then just the same way that you inherited from my code in your airline and flight class, now we're inheriting from this Jakarta API code for our servlet class, and that provides the do get and the do post. And so this is then the interface between your code and Jetty. So when it runs in Jetty, and here again, we're running in Jetty over here on the right. This is the web application. Okay, so that's really cool. That's really great. But then basic question, how do you test this code? Because this code expects, your do get method expects to be sent in an HTTP servlet request and an HTTP servlet response. And so then, how would I test this code if I need to have these request and response objects? Of course, one way to do it would be to always test this code inside inside a running web application. And actually, we'll see how to do that. But there are some barriers to that. One is that you're not really testing the code directly. You're testing the code in the context of the servlet container, and therefore, the test itself has to interact with URLs. Doesn't really interact with the code itself. So that's not a unit test, right? That's pretty complex because in order to run it, you have to run your servlet inside of the web container. What I'd really like to be able to do is write a unit test for this, something really easy. But in order to do that, I need to create these servlet requests and servlet response objects. So if we just take a look at what this HTTP servlet request is, it's an interface. It's an interface that's here that comes part of the Servlet API from Jakarta up here. And it's got a bunch of methods like get auth type, get cookies and stuff. And so then one approach to doing this is that you could write a unit test that invokes do get, and you would provide your own implementation of this interface. And so you could create a pretend or really a testing an instance of or a class that implements HTTP servlet request that's used only for testing. And then what you could do is, I guess you could say, hey, give the ability of that test object to be able to answer, hey, when you set content type, what content type did you set? And the same thing you have to say, oh, well, when get parameter is, passed in, return the value that I expect. And you could do that. And that is, that is something that's perfectly possible, right? Implementing your own. But as we're about to see, there is an API that does all of that for you, and it's called Mockito. There's a lecture all about testing with mocks, and it's actually one of the most advanced topics in the course. It can seem pretty magical at first, and it can seem a little confusing, but I do encourage you to dig into it to really understand what it's all about because it's a very powerful testing tool. And so we'll begin right now by talking about how to use Mockito to test the airline servlet. So over here in our airline web project, we have some test code, right? We have test Java, and then here's the test code. So we have airline servlet test right here. And let's take a look at what this test does. I'm going to run it first to make sure that it runs okay. But what this test what this does is it uses this Mockito API to be able to call the do-get method directly. And instead of having to implement your own HTTP servlet request and servlet response, what is this? Self-attaching? That was an interesting message there. Let's see. Mockito is currently self-attaching to enable the inline mock makers from no longer work on future releases of JDK. Please add Mockito as an agent to your build. Oh boy, that sounds exciting. Okay. So it looks like it's using some feature which might be going away sometime. Okay, well, I'll keep an eye on that. But I think the important thing to note here is that we were able to run the test. Both tests passed, and oh, good, we saw some output, kind of like we expected. Stuff is written standard out. Cool. That means that your that the servlet is actually being invoked. But let's take a look at this test and what it does. Okay, so what I want to do is I want to have a test that says, A, initially the servlet contains no dictionary entries, right? Very basic test, but it sort of ensures that when you go to when you say, hey, get me the entries in the dictionary from a newly created servlet, one where no dictionary entries have been added yet, that yes, it is empty. So how do we express that? Well, I mean, first thing we do is create a servlet, which you can do right outside in just plain old Java code because this is there's just a zero argument constructor here, right? At the end of the day, the servlet is just a Java class, right? Other than the fact that it depends on some servlet APIs. There's nothing magical about this, right? So you can create one. You can say have a unit test that creates one. But the challenge is like, well, do get what request do you send in and what response do you send in? And as I was saying, well, HTTP servlet requests and HTTP servlet response are just interfaces. So there's not a lot of magic there either. There's nothing special there either. And this is where the Mockito API really shines. So what Mockito allows you to do, this is where where it shines and where the magic happens. It has this method called mock. And what mock does, and you can learn more about this in the lectures, is that it You give it the name, you give it a class reference to an interface, and it returns an object that implements that interface, but it has these special properties. It basically you can take that mock object and you can tell it to behave in certain ways under certain conditions. Basically, you basically set up the test the way you want it to behave in the test, and then you can interrogate that mock object about how it was how it was interfaced with, how it was used by the code under test. And here's an example of how to do that. So when we call our doGet, the request and the response that we send in are these mock requests and responses. And so then when we think about what the doGet method does, let's think about how it interacts with the objects that it's provided. Well, what does it do? Well, it will, how does it use the request? Well, the request is used in the call to get parameter. And oh, it also uses and how does it use the response? Well, the response is used to set the content type. And the response is used in write definition and write all dictionary entries. Okay, so this is good. Oh yeah, I guess the response, do we not write? Oh yeah, and we also call set status on it, right? So these are how the objects are interacted with. And when you're thinking about these more complex, complex objects like the servlet, you need to think about how it interacts with the objects that are provided to it, like the request and the response. Okay, so knowing that that's how we interact with the request and the response, we know that in order for doGet to be successful, it needs a couple of things. It needs a request, it needs a response. And we know that it'll need a print writer, right? So as you recall, we also call response.get get writer over here in the methods that like write the dictionary or write the dictionary entry. And so then we want to make sure that it has a print writer to interact with. And so we create a mock print writer. So it's super cool. Again, we don't need to use a real print writer. It just create me a mock one. So all we need is a print writer that basically behaves as we expected, meaning that it doesn't really blow up when you try to call print line on it. And then we need to wire up the response object to return this mock print writer when its get print writer method is called, and we do that here. We say when, this is another mockito method, we say when response.getWriter is invoked, then return this mock print writer that I created there. So I'm just going to, I'm pausing here for dramatic effect because this is what mockito lets you do, and actually it's pretty super cool, right? It allows you to create these these mock objects and then program them in the way that you want. So you say, great, here's my mock request, here's my mock response, and when my getWriter method is called, so it's the same getWriter method over here. It's basically saying, hey, this mock response that's going to be passed in, its print writer, is going to be this mock print writer. And otherwise, getWriter on the mock object will return null. You get a null pointer exception. And actually, maybe we can. We should probably let's show that. Well, we'll show that in a moment. But we basically program your mock objects, or you train your mock objects to behave in a certain way, and then you just call your code under test doGet. And when this is called, it'll interact with the mock request and the mock response, and it'll do whatever it does. And then you can use this verify method from mockito to to assert that the mock objects were interacted in the way that we expect. So in this case, because there are no entries in the airline servlet, we expect that nothing is ever written to the print writer. So we can assert that fact by saying, hey, verify that the print writer's print line method is never invoked with any string, right? So there's this notion of matchers in mockito, which again you can learn about in the lecture. But basically, we're saying, hey, listen, make sure that you're never calling print line, because that's what we expect in this case. And also verify that set status is set with the value scok, which is actually what we do right here. So let's run it and see what it does. So the whole idea here is that we are testing this method. We're testing how doGet interacts with its request and response. And so we have to set the appropriate preconditions with the request and response object, so that it will so that the do get method will do what we expect it to do. So good, that passed. If I comment out this code that says the print writer and run it again, oops, this won't compile because I need to comment that out too. Sorry, let's see here. Yes, yes, yes. We'll run this again. Okay, it failed because it said, hey, cannot invoke object.get class because writer is null. So then if we look at the code that failed, actually this is the text dumper. So then the writer that is passed in to to this text dumper is null, which isn't terribly surprising because that writer comes from the print writer that came from the response. My screen was just a little bit bigger, but I don't want to make the text any smaller. Anyway, so again, here we call response.getWriter, and when this is invoked, when this response in the test is this mock response that we had over here in our test, and that's why you need to have that mock response. So we'll just undo these comment out lines, and then we'll see that now when we pass in an actual real non-null print writer from the getWriter method. So when this getWriter returns a non-null value, we get what we expect. Ooh, this is taking a while to run. There we go. Cool. Now it's happy. So those are some of the kind of things that you can do with the mockito library. Again, you create these mock instances of these interfaces, and then you program it to do what you want, and then you invoke your code under test, and then you verify that the mock objects were interacted with as you expect. And what this allows you to do then is test this rather it allows you to test an object like airline servlet that has kind of complex dependencies in isolation without having to run it inside of the servlet, or inside of the server container. So this is a test that comes out of the box. Here is another one. Add one word to dictionary. So here we're going to test get post, or do post, sorry, do post when you add one word to the dictionary. We're basically going to say, hey, create the situation under which a dictionary entry ought to be added, call do post, and assert that what you expect happened. And again, let's just look at the do post method. It's right here. What are some of the things that we do? And here again, we're kind of testing after the fact. When we refactor things in class in week after next, we will we'll actually do test from development. Here we have these tests in place so that we can learn about the Mockito API. But what does do post do? Well, it goes and gets the parameter, and the name of the parameter is word, right? You may recall word equals do or ray or me or whatever. And then we have logic like issuing a missing required parameter error, and we'll want to test things like that, and we can do that with Mockito by then validating that the response object is interacted with as we expect. Oh, we also have log. Well, anyway, and then ultimately, though, what we want to do is verify that yes, once the post is, if the post is successful by adding a word in a definition, we get the interaction with the response that we expect, and I'm pretty sure we validate that yes, the word was actually put into the dictionary, which you can do in a unit test. You couldn't do this if it was, no, you couldn't do it effectively if it was running in the servlet itself, because the test wouldn't be able to get access to this object. But I'm getting ahead of myself. Okay, let's look at how we interact with this. Again, we're going to create our servlet, and ultimately we're going to invoke doPost on it. Now we need some test data, so we'll have a test word and a test definition. And now we're going to mock out the request and the response so that we can we can interact with the doPost method. So I'm going to create a new mock request here, and I'm going to configure it to do a couple of things. I'm going to say, hey, listen, when on this mock request, when get parameter is called on the request with the value of word parameter, which is word, right? Then I'm going to return, well, the test data, the test word. So this is exactly what ends up happening when you invoke the URL for real from a browser or from the command line. It creates a what Jetty will basically give you is a request object that when you call, when you invoke, say, hey, give me the parameter for word, it's going to return whatever you passed in. So we do that for word and we do that for definition. So again, this is mocking out how the request object behaves in this test. We also want to mock out our response, and in this case, because there will be information that is written to the response's print writer, we want to be able to capture what is written so we can verify that it's what we expected to be written. And so the way we do that is as follows. So instead of configuring the writer to return a mock print writer, we're going to have it return a real print writer. And this real print writer is going to be created around a string writer. And a string writer is, well, it implements the writer interface and it buffers things up into a string in memory, which you can then get. You can get that string by calling toString on the string writer. So that's the print writer that we're going to use with this particular mock object, with this particular mock response, is going to be one that writes to a string writer. Okay, we have our request, we have our response, and we're going to call doPost. And now we are going to interrogate the response object and, well, the string writer that was attached to the string writer that was accessed through the mock response to make sure that it behaves as we expect. So the first thing that we're going to do is use assert that. So this is plain old Hamcrest APIs that you've been using the entire time. You can use that too because we're just dealing with Java objects at this point. We're going to say, hey, assert that the value that was written to that string writer through the print writer that was returned from the response contains the string, well, this defined as words. And so then this defined as words is just a helper static method that formats things. It actually makes it easier to test. And so then I use that here in both the test and the code under test, because as you can note, yeah, we use it over here too. When we write to that print writer, we just say defined as words. So we make sure that the text that we expected was written to the print writer. And now we do something else also. I also want to validate that that what was written to the status code is that SCOK, is the SCOK right here. And this was written to the status for the response. Okay. Well, how can we do that? Actually, we could just do what we did up here. Honestly, we can just say verify that response.setStatus equals SCOK. But there's another technique from mockito that I wanted to show you, and that is using something called an argument captor. So here, what you can do is you can use verify, and you can say verify response set status. But instead of just setting in the constant value, like we did up here, we can capture that value to then do more things with it. And this is often very useful. It helps you really do more with, especially if this is a complex object. You want to use argument captor so that you can do some more stuff with it. So what we do is we create this argument captor object by using argument captor.for class, and then you give it the JavaLang class for the type of argument you want to capture. And then you say, for this argument captor, say status code.capture, and what this will do is, well, verify will then populate the argument captor with the value that was invoked with set status. Then you can call getValue on the status code argument captor to get the value, and then we just use a Hamcrest assertion, assert that is equal to SCOK. So that's an example of using argument captor. As I point out here, it's very helpful when you want to make multiple assertions against a value, which we didn't do here, but again, it's just an example. And finally, I want to assert that. So anyway, I assert that the appropriate or the expected information was written to the servlet response. I assert that the expected value was returned in the status code of the servlet response. And I want to make sure that the definition was basically written to the map. And the way I do this is through this get definition method. Get definition is a good example of a method that is only exists for testing purposes. So the application itself actually doesn't call this. Um, and that's fine. Instead, what we do is that we have this method, and what does it do? Well, it returns. It looks at, internally into the database, the Java, util map that holds the dictionary, and returns the definition. This is a very common thing to do and a good thing to do because there's sometimes you need behavior just for testing, not for implementation purposes. And so there are a couple things about this. Notice that it's not private, it's not protected, it's package level, so it's default visibility, which means that another class in the same package. So in this case, well, they're both um, in my in my in my package. Um, the test class can invoke it. It has visibility to be able to invoke it. And I use this at visible for testing, which is an annotation that comes from the Guava library from Google, which is just a documentation annotation that lets you know it's like, hey, the reason that this isn't private is because it's used for testing. I find that helpful to just as a clue. It's like, oh yeah, right, this method exists for tests. So basically, what we do there is use that definition to then validate that internally the dictionary entry was persisted. And so then that's how you can write a unit test for the airline servlet. Again, you use these mock objects to create things like the request and the response, and then you program them for. I think that's well. Use a train or program. Probably train's more AI like, so maybe you can get credit for AI in this class because you trained a mock object. Probably not. You can configure them to behave the way that you expect or the behave that you want, behave the way you want for the test. It's just another form of passing in test data, right? Just the same way that if you had, oh, let's say you had a method that was validating that you could parse a date in your projects 1 through 4, and you pass in some test data. Well, here you pass in some fancy test data. You pass in these mock objects that then behave in the way that you want for that test. So basically, provide the test scenario, the given for the given when then. And then you use methods like verify to to verify that the mock objects were interacted with in the way that you expect. So meaning that, oh yeah, like for instance here, nothing was ever invoked on the print writer, and that here the expected status code was invoked with on the response. So that's the airline servlet test. There's another unit test in here that does something similar for the REST client. And I don't think there's anything terribly new here. I think what I will point out though is a design decision. Yeah, a design decision that we made with the airline REST client. So recall that the airline REST client, I'm going to move this over to the right so that all the code under test is on the right. Move to the opposite group. Airline REST client, so this is okay. This is on the client side of the program. So like back here, right over here in the command line program, this is where the REST client is used. So this is the thing that will ultimately put together the URL that is then fetched from the servlet running over here, right? So maybe I should have the code on the right, but on the left. But anyway, but here's a REST airline client. And it's the thing that, well, it basically gives you a fluent Java API that speaks the language of um, of the application of the domain. So here it speaks dictionary, right? So oh, you get all dictionary entries. And I guess I really didn't highlight this on Wednesday when we talk about it, but that's the whole purpose of the airline REST client. Again, it provides a fluent API so that things like your main method can interact with something that looks basically like the application. And so then what we're going to do week after next is we're going to replace things like this dictionary with an airline, right? That's what we'll be doing. We will, on the client side, we will be modifying this REST client to speak the language of airlines instead of speaking the language of dictionaries. Okay. Um, so if we go and look at this interface, then let's see here. Right. So then, um, what this does is it goes off and uses this get method of this HTTP class to then invoke the REST API. And again, there's logic here. We want to be able to test it, but we've got this big dependency, right? We've got this big dependency on this HTTP request helper object, which is the thing that's responsible for making all of the again, this is a class that I wrote. This is the thing that uses HTTP URL connection to make the connection. And boy, in order to test this code, you'd have to have something on the other side to respond to that HTTP request. So that means you have to have your server running, and that means every time you run your test, you have to start up your server, and it would get slow, right? I mean that's heavyweight. That's more heavyweight than you want out of a unit test. But I really like to be able to test the logic that's here in these methods, because there's a couple of things. So so what I want to do is I want to mock out the behavior of this HTTP.get, right? So instead of having to actually make a real HTTP call, I just want to mock it out and just have it return a response that behaves just as if I had made a real call, and then deal with the ramifications of that, just sort of using my regular code. And so anyway, and so once again, over here in this unit test, this is how you do that with Mockito. So we're gonna mock out our HTTP, and notice that the airline REST client has a constructor that takes an instance of HTTP request helper. And notice that it's visible for testing. So normally, what you do when you create one of these things is that you would pass in a host name and a port. Well, in this unit test, we don't have a host name and port because there's not really a web container running here. Instead, what we do is we have this constructor that just takes some HTTP request helper. We use that constructor here in the public one, in the real one that people use, just by calling this and sending in. Here is the HTTP request helper, the real object that we create with that URL prefix. But for the test, we just use this constructor. And so this allows you then to pass in a mock HTTP request helper, which is exactly what we do here. So we create a mock HTTP request helper, and we program it. We train it to do what we want. So basically, what we do here, and this uses some stuff from the Mockito API until it gets a little complex. What we do here is we say, well, hey, when the get method is invoked, and actually let's look at the get method again. It takes a map. Okay, this is another map, and these are the parameters that are sent to the URL. So these are the key value pairs, like doe and doe equals deer, female deer, or in the case of your airlines, there'll be information about the flight, the airline name, and then the source, the destination, and the arrival time, all that kind of stuff. So that's that map of parameters there. And we want to say, hey, listen, when get is called with an empty map here, and so with a value equal to an empty map, then return this dictionary as text. And this is a method down here that basically converts a map, dictionary. So 1, 1, 2, 2. And actually here I should probably have these are words and definitions. That would probably make for a better thing. It'd be like word 1 definition one, word two, definition two. Should make a note to fix that. That we then we'll take that map and use our text dumper. So this is a nice use of a text dumper for testing purposes to then dump that dictionary as text to a string writer. And then what we'll do is we'll return this response object, which is what get returns, right? It returns one of those response objects with the contents of the text dumped dictionary. And recall in this case, it'll be the XML dumper that you all will use. Again, this is pretty complex, pretty advanced, but it allows you to have a unit test here. So like when we send in this mock HTTP helper, HTTP request helper, then you can just call this get all dictionaries entry. Sorry, get all dictionary entries. And instead of, because we use the mock HTTP request helper, instead of actually making a call out to the servlet, out to the servlet that's running in some web container, it just ends up invoking, well, this get dictionary as text. But you know what? The code that's under test, this get all dictionaries method, it doesn't know and it doesn't care. Again, this is programming to the interface, right? It's the whole idea. Because it's just saying, yeah, it's called get on whatever HTTP object I was provided. Right. It doesn't really care that it's a mock object. It's going to get the response and it's going to do what it wants to do with it, right? It's going to check to see if there's an exception. Otherwise, it's going to parse the content returned from the response, which actually is what you sent it right here, parse it back into a map. And again, this map is the dictionary, and then return it here. And again, that's what we do. We say, yep, does the map that's returned by all dictionary entries equal to, well, this dictionary that I use for my test purposes? And so when we run it, it ought to pass. What you'll see us do again in class in a couple of weeks is replace this dictionary with an airline, and we'll refactor our way into morphing this this application from a dictionary to an airline application. Good, and that thing passed. And we can do it via unit tests using Mockito. Admittedly, this API takes a little bit of getting used to. Again, it's one of the more advanced things in the course. And so if you find yourself having to go back and look at the slides for Mockito again, or do a little bit extra reading on Mockito, or watch the video, don't worry, that's as expected. But let me tell you, this is really powerful stuff, because what it allows you to do is implement things like your REST client and your airline servlet with just unit tests. Using test-driven development, you can go much faster than having to implement a whole bunch of your application, go back to the command line or do things from the browser. That's really heavyweight. That'll slow you down. I think as you'll see is as we refactor things, the unit tests allow us to work very quickly. Okay, so that's unit tests for Project 5. And we'll see some more in class. There's also integration tests for Project 5. Now, in projects 1 through 4, integration tests were all about interacting with the main method. And the main method was unique because it took arguments from the command line, and really what it did was then, the inputs were from arguments from the command line, and the output was things that were written to standard output or to standard error. And so in that respect, what you were integrating with is the command line and standard output and standard error. And the invoke main test case framework allows you to capture allows you to invoke the main method with an array of strings. That's not such a big deal. But what's interesting about it and why it's necessary is that it captures what was written to standard output and standard error so that you could validate it, so that you could ensure that your program behaved as you expected. And so that was a pretty basic example of an integration test. And honestly, as you probably saw, those integration tests runs just as quickly as your unit test, because there's not a lot of there's nothing outside of the program that has dependency on. However, here in Project 5, there is a big dependency, right? And that is the servlet. That is the code running over here in the web container. And you want to be able to test the servlet sort of in its natural environment running inside a web container. But in order to do that, you need to start up Jetty and then you need to run your tests against it. And that is slower than just running the unit test because you got to build the whole WAR file and deploy it to a web container, and then you can run your unit tests then you can run your tests, and what those tests will do is make real world calls, real live calls to the REST API through the server container and all that kind of stuff. Actually, I could be showing the diagram from the assignment, and I think you'd see where all this stuff lives. That's clearly not a unit test. That is an integration test because it really does integrate two different processes. And so then we've got integration tests here. So let's look at the Project 5 integration test. And I'll put it over on the left where all of the test code lives right now. And Project 5 invokes the main method of Project 5 IT invokes the main method of Project 5. I'll move this over to the right. And this is the main method right here. So it invokes the main method using invoke main test case. And so then here's invoke main. Like we expect, right? This is all familiar to you, I hope, by now from your projects 1 through 4. But here, and what invoke main does is it provides some stuff on the command line, and then it gets the text that was written to standard error, just like in projects 1 through 5. Except that when you do invoke the main in turn makes the REST API call. Right, by using the airline REST client to make the REST API call. And here we're not using any mock objects. This is the real code under test, or rather the real callers of airline REST client. So this thing is created with a host and port, which will then have it call the REST API for real. And so then in order to for this to succeed, there must be a servlet running inside a container that will support. That will host that URL and respond to all of that. So this means that in order for these tests to pass, in order for these tests to pass, the servlet must be running. So I'm going to run these tests. I do have the Jetty running right now, so I'm going to run them, and we'll see that this invokes the main program. Yep, everything passed, and also you'll see that a whole bunch of stuff was written out to standard output because the servlet was invoked. And you'll also notice that if I then stop Jetty and I try to run my tests again, all sorts of stuff will fail because Jetty's not running and there's nothing to So because it got connection refused when it tried to call the delete from the from remove all dictionary entries. And same thing for here. This is an interesting one. Here, what we were doing is we were asserting that there was some text written to standard error. We expected that to be empty, but instead what we got was this error message while contacting the server, connection refused. Again, so these tests rely on Jetty running. And so in order to run them here from IntelliJ, we have to have Jetty running. However, we also want to be able to run our integration tests through Maven. And if we run Maven W, do I want to do a clean? I could. I can just run verify. If we run Maven verify, when it goes to run the integration tests, before it does so, this Maven project has been configured to start up Jetty with and deploy the application that was built to it to run the unit tests against. Or sorry, run the integration tests against. And so now, actually, we saw it going by here in the logs. All of this is, this should look familiar. This is the same warnings that you get when you start up Jetty over here. But then it went and, started, the server connection over here. And then it ran the tests. And as you can see, there was some output when the tests were run. That's cool. And then it's stopping Jetty here at the end. But again, this was all taken care of for you by Maven. And so then, your integration tests are basically true integration test now because it's running your methods like main, and actually there's also one for airline REST client. There's an airline REST client integration tests that also will create a real airline REST client with a host name and a port. And then this is the thing. This is the code that basically tests the real REST API from this airline REST client, which again provides a fluent interface over for the application. You get all dictionary entries, and we'll morph it into or refactor it into get airline. I think is what we'll change that one into in class in a couple of weeks. So, and again, though, because this is an integration test, there's really no magic here. We can just go and get the object, and then we can interrogate it, to make sure that hey, here, initially when the server is empty, there are no entries in the dictionary, and then we can do things like test defining one word, or test that. Actually, this is a neat one. If we use the airline REST client to request the definition for a word that doesn't have one, we verify that the code throws this REST exception, and that the status code for that REST exception is error code 412, which is, let's see here, I think if we look into post, I'm sorry, that would be do get. Instead of get all, it would be, get definition. Oh, I'm sorry, that's the client. I want the servlet, and if we go to this, do post. When we go to get a word and the definition is null. Actually, well, here, if the, I'm sorry, no, we want to do get. Right definition, yeah. Here, if we go and look at the definition in the dictionary and it's null, then we set the response on the HTTP servlet response to not found. And that gets percolated, so that's a 404, that gets percolated back to the HTTP request helper. That 404 gets percolated there. And when the HTTP request helper, let me go find that. HTTP request helper. When, we go off and make the request, and when in the response, we use this HTTP URL connection, which is a built-in Java class from java.net, to get the status code, and then we return, and then we store the status code so that it can be fetched from this exception object. So the whole idea here is that HTTP request helper throws an exception when there's anything except an HTTP code 200 returned, which is a Java thing to do, right? I mean, when you make when you make a method call and something goes wrong, you want an exception. That's exactly what this does, and this code tests it by saying, hey, when I look up the definition for when I try to add a dictionary entry to the empty string, then we get the exception that we expect. Anyway, this was a tour of how Project 5 can be tested. And Project 5 has the same requirement as the first four, that your code needs to have 75% test coverage, and there's a lot more code in this one, right? In addition to like your pretty printer, your XML parser dumper, you have your servlet, you have your REST client. All of that needs to be tested, or needs to have sufficient test coverage. So I know this was a lot. I know there's some things that are probably new and you'll need to explore more on your own, but I wanted to give you this overview and introduction to the tests, so that you can view it asynchronously. Because then when we refactor it in class, you'll see how we can use these tests to gradually and incrementally refactor this dictionary application into an airline application so that it's easier, well, and so that we can get started on the meat and potatoes of Project 5. Awesome. Okay then. Good deal. Thanks for watching. Hope this was insightful. I will see you in class on Monday. Now.